Hey, what up peeps? This is Walker Miller, and we're going to be doing rate law with kinetics. Rate law is the rate at which a reaction occurs, and it's expressed with this equation right here. Rate equals K, the concentration of A to the M, concentration of B to the N. The rate is the rate of disappearance of reactants, and the units for that is molarity per second. We'll skip down to M and M. Those are the reaction orders in terms of A and B. And A and B, by the way, are always going to be the reactants. It's never the products. K is the rate constant specific to the reaction and at a certain temperature. And K's have funky units. It depends on the overall reaction order and added together. So let's say M is 1 and N is 1, so you add it up, that's 2, which gives you the units here in my fancy table. M to the negative, molarity to the negative first, and seconds to the negative first. So that would be units for that reaction. And for the math, we're going to do a question from the free response equation using this reaction right here. This would be a free response question. So we're given this table right here, which gives us rates for certain trials and the concentrations of the reactants and their disappearance. So the first question is, using the information in the table, determine the order of the reaction with respect to each of the following. Justify your answer, and you justify your answer with the calculation. So the first one is Cl minus. So you start off by writing the rate law without the M and M in it. So we have rate equals K, concentration of H plus, to the M, concentration of Cl minus, to the N, concentration of MnO4, to the O. And so this is pretty much the generic rate law. So how we find rate, or the orders, is you look at our table here, and they have 3 trials, and they have 3 different rates. So we look at the concentrations over here, and it says just find Cl minus and MnO3, so we're not really worried about H plus because that stays the same the whole time. So we look at these, so we look for, if we're finding Cl minus, we want to see where the concentration changes. So from trial 1 to trial 2 it changes, and then we need to look for where permanganate stays the same. So that in trial 1 and trial 2 it stays the same. So we're going to write it as like a proportion. So we'll write the rate of trial 1, 2.25 times 10 to the negative 8th, over the rate of trial 2, 2.03 times 10 to the negative 7th, equals K, concentration of H, which is 3, to the M, concentration of Cl minus, which is 0.0104, and to the concentration of permanganate, which is 0.004 to the O, over K to the concentration of H, which is 3, M, and then concentration of Cl minus for trial 2, which is 0.0, and concentration of permanganate, which is 0.04 to the O. Alright, and so since you look over here, you can see that some of these are the same, so we can just cross these out. The K, concentration of H, and permanganate. So that's why we want the Cl concentration to change, but we want a trial where the concentration of permanganate stays the same. So now we're just left with the rates and concentration of Cl minus and the exponent. So we're left with 2.25 times 10 to the negative 8th over 2.03 times 10 to the negative 7th equals 0.0104 to the N over 0.0312 N. And then you grab your calculator and plug it in. So you plug it into your calculator and you get 0.111 to 3 sig figs equals 0.333 to the n. And so you have to look at this and see what number for n will get me 0.111. So you plug in 2, see n equals 2, and 0.33 to the second equals 0.11. So we know that CL minus is second order, n equals 2. And now we have to do the same one for the same kind of steps for permanganate. So when you do the math, you get the rate of trial 2 over the rate of trial 3, and the concentration of trial 2 for MnO4 minus over for trial 3. So, and then that's to the m. These are m's, by the way. And when you plug it in your calculator, you get a number super close to 2 equals 2 to the m. So we know m has to equal 1 in order for that to work. So the order of permanganate is 1. The information in your answers to part B above complete both of the following. The first one is write the rate law for the reaction. So pretty much all you do for that is you plug in the orders you found. So we have rate equals K concentration of H, which is third order, concentration of Cl minus, which is second order, and concentration of MnO4. So you can see, unfortunately, this isn't like equilibrium. You don't use the coefficients of the reactions as your exponents. You actually have to do the math to do it. So that's part 1. Part 2 is calculate the value of the rate constant K for the reaction, including appropriate units. So that's pretty easy. You just take your values from the table above that you're given. You pick any trial you want and you plug it into your equation. So I'll just pick trial 1. Alright, so solving for K, you take the rate law that we found, which is this, and you just plug in one of the trials. So I plugged in trial 1, and you solve for K. So you do the algebra side, divide that side by all these numbers, divide that side by it, and you get K equals that over all that. And when you put it in your calculator, you should get a number that looks like that. And the units for K, we pull it out our handy dandy table here. And so you look at the reaction. 3 plus 2 plus 1 means it's a 6th order reaction. So as you can see, it starts out with for 1 order reaction, it starts out with just seconds to the negative first, and then the m just increases in -1 to -2 and so on until you just follow that down the table to 6th order until you get -5th molarity per second, and that's how you find K. Alright, and the last question on our free response question is it likely that a reaction occurs in a single elementary step? Well, I'll just talk through this one. As you can see, here's our reaction, and you can look at the coefficients of the reactants. It's H plus is 8, and then 4, and then 1. And if you look at the order of our rate law that we calculated for, it's 3, 2, and 1. So that's not even close to the coefficients of the reaction. If it were an elementary step, then you wouldn't see that the coefficients were matched up. But since they don't, we can see that it is not an elementary step. And also you could explain it by that there is 13 particles here that have to collide all at the same time in order for this to occur, and for that to occur all in one elementary step is highly unlikely. So yeah, there you have it. That's how you do rate law in kinetics. So thanks for watching my video.